In this example, we're going to be showing you on how to do detailed analysis on an algorithm that computes the summation of all cubes from 1 up to n, where n is a positive integer. We're not going to explain how the algorithm works or how the summation is calculated. However, we're going to identify each operation in this algorithm and how many times each of these operations is executed. So let us find out what are these operations. The name of the algorithm is sum, and it has a single parameter that is called n. The first two lines are comments, and as you know that comments are ignored by the CPU, so no time is spent to execute comments. In line 4, we have an assignment operation, and in line 5, we have a for loop that goes from 1 up to n. And as you know that for a for loop, it consists of 3 parts. The first part is the initialization part, which is an assignment operation. The second part, which is a condition, that is a comparison or testing operation. And the last part is the update for the value of I, which is an increment operation. In line 6, we have an arithmetic statement that is inside the body of the for loop. This statement consists of 2 multiplications, 1 addition, and 1 assignment operation. Finally, in line 7, we have a return operation for the return statement. In the beginning, let us assume that each operation takes different amount of time to execute. As an example, we will assume that the time to execute the multiplication is not the same as the time it takes for addition to execute. And similarly, for the addition, we will assume that the time it takes to execute is not the same as the time it takes for the assignment to execute. So this is our first assumption for the detailed analysis. So we will assume that each operation takes different amount of time to execute. Now in this table, we are listing all operations exist in this algorithm. For the assignment operations, we assume it requires C1 unit of time. And for the increment operation, we assume it requires C2 unit of time. And for testing or comparison operation, we assume it requires C3 unit of times, and so on for the rest of the operations. To find out how much time it takes for each operation to execute, we will build a table, and in this table, we will list all operations and how much time each operation takes to execute. So this is the table. In here, we will write the line number, and in here, we write the operation, and here we write how much time it takes for this operation to execute. So let us go over the algorithm line by line. We will start with line number 4. So here we write line number 4, and the operation is the assignment operation. This operation requires C1 unit of times as indicated in this table. So in the time column, we write it requires C1 amount of time to execute. Now in line 5, this is for the for loop. As we've discussed, that it consisted of 3 operations. The first operation is the assignment. It takes C1 unit of times, and it is repeated only once. Next is the testing operation, or the comparison operation. As indicated in the table, it requires C2 unit of time to execute. But how many times it is executed? According to the semantic of the for loop, 1 comparison is needed in each iteration to test the value of I against n. Plus, 1 more comparison is needed, that is the last comparison, to stop and exit the loop. Now since we have n iterations, then the total number of times the testing operation is executed is equal to n plus 1 times. So we multiply n plus 1 by the amount of time for the testing to execute. Finally, for the for loop, we have the increment operation. And this operation, as indicated in the table, requires C3 unit of times, and it is repeated n times because it is executed for every iteration of the for loop. Next is line 6. And in line 6, we have a statement that is inside the body of the for loop. This statement consists of the assignment operation, the addition operation, and we have two multiplications. So let us start with the assignment. So we have an assignment operation in this statement, and the assignment operation requires C1 unit of times, but it is repeated n times. Why? Because the statement inside the body of the for loop is repeated n times. Next is the addition operation. And this addition operation requires C4 unit of times, and similar to the assignment operation, it is repeated also n times. And for line 6, finally, we have the multiplication operation, and we have two of them, and each of them requires C5 unit of times. So we write 2 C5, and each of them is repeated n times. Finally, for line 7, we have the return operation, and this return operation requires C6 unit of times. After computing how much time it takes for each operation to execute, now we are ready to calculate or compute the time complexity or efficiency of the algorithm. The time complexity is simply the addition of all times required by each operation to execute. In other words, we take the summation of all these figures. But before that, we need to discuss what is the problem input size, because the time complexity will be expressed as a mathematical function in terms of the problem input size. To find the problem input size, we will go over the operations and find their running time one by one. The numerical parameter that affects their execution time will be considered the problem input size. So let us start with line 4. In line 4, we have an assignment statement that is repeated once, so the execution time is constant. The next operation is the assignment for the initialization part of the for loop. Also, it requires constant amount of time. But for the testing operation for the for loop, it depends on the parameter n. So when the value of n is increased, then the execution time of the testing operation will also be increased. So therefore, the execution time of the testing is increased if the parameter n is also increased. Similarly, for the increment, assignment, addition, and multiplication operations, all depend on the value of n. If the value of n is increased, then their execution time will also increase. Since this parameter influences or affects the running time of the execution of these operations, then we can consider n as the problem input size. So let us express the time complexity in terms of n. So here we write Tn, and we add all of these numbers. So C1 for the assignment in line 4, C1 for line 5, the assignment, plus C2 times n plus 1, plus C3 times n for the increment of the for loop. Now for line 6, we have C1n plus C4n for the addition, and here we have n, plus 2C5n for the multiplication. And finally, we have C6 for the retain operation. Now after simplifying this equation, this will be equal to 2C1 plus C2 plus C6. We are putting the constants in one side. And for the constants that are multiplied by n, so here we say that we have n multiplied by C1 plus C2 plus C3 plus C4 plus 2C5. Our next step is to find the asymptotic notation for the time complexity, and we will use big theta for the asymptotic notation. Remember that for the asymptotic notation, the constants are ignored. So therefore, to find the asymptotic notation using big theta, these constants will be ignored as well as these constants also will be ignored. So the final result will be Tn will belong to big theta of n. Since the execution time for each operation is ignored by the asymptotic notation, to simplify the detailed analysis, we will consider each operation takes the same amount of time to execute. In this case, we're not going to talk about the execution time for each operation. Instead, we will talk about the frequency of each operation and how many times each of them is executed. So let us write this assumption. So here we assume each operation takes the same amount of time to execute. We will assume 1 unit of times. So what will be the equation for the time complexity? So for the time complexity, we will replace every value of Ci by 1. So it will be equal to 1 plus 1 plus n plus 1 for the comparison, plus n for the increment, and a plus n for the assignment in the arithmetic statement, plus n for the addition, plus 2n for the multiplication, finally plus 1 for the retain operation. And again, when we take the asymptotic notation for the time complexity, these constants will be ignored. So at the end, we will say that Tn belongs to big theta of n. So as you can see that the execution time is ignored in the calculation of the time complexity. And we will concentrate only on the frequency, on how many times each of these operations is executed. And at the end, these constants will be ignored by the asymptotic notation. And this completes the detailed analysis of the algorithm. Now let us inspect the algorithm again line by line. Notice that the algorithm is spending most of its time executing the operations of the arithmetic statement in line 6. Why? Because it is the statement inside the algorithm's innermost loop. So we will consider only these operations, the multiplications, the addition, and the assignment, and how many times each of them is executed. Then we will calculate the time complexity. This will be the third step. And in the third step, we will consider only the operations of line 6 and ignore all other operations in the algorithm. So what will be the time complexity by considering only these operations? We say Tn, and we will write how many times the assignment is executed. It is n times. For the addition, n times. And for the multiplication, it is 2n times. And again, for the asymptotic notation, for this final result belongs to big theta of n. So here we write Tn belongs to big theta of n. So it is unnecessary to consider all operations to find the complexity of the algorithm. Instead, we can consider only the operations of the statement that is consuming the execution time of the algorithm. In our example, it is the statement inside the for loop at line 6. After locating the most time-consuming statement, now we will select the most time-consuming operation in this statement. We have 3 operations: the assignment, the addition, and multiplication. And as you know that multiplication takes more execution time to execute than addition and assignment, we will consider only the multiplication operation in line 6 and ignore all other operations in the algorithm. So the time complexity in this case will be equal to 2n, which is the number of times the multiplication is executed. And as you can see that Tn is also belongs to big theta of n. Now this operation is called the basic operation. So here in our case, the multiplication is called the basic operation. In conclusion, detailed analysis is time consuming because it counts the frequency of each operation in the algorithm although the same result can be obtained if we consider only the frequency of the dominant operation, which is the multiplication operation. And this multiplication operation is called the basic operation. So in the detailed analysis, we count every operation, how many times it is executed. But if we concentrate only on one operation that is called the basic operation, then the analysis will be called a quick analysis. So it is practical to follow the quick analysis, because in the detailed analysis, we do counting for unnecessary operations that do not contribute much to the efficiency of the algorithm.